Welcome back everyone, Patrick here. Moving on to the next video, we got to find the values of x that satisfy each inequality over here. So starting with number one, we got to find out when does 3x minus 5, when is that less than or equal to 16? So basically the way you treat this is like a regular equation. You want to isolate for that x. So what I'm going to do here is I'm going to bring the negative 5 over. So we'll have 3x is less than or equal to 16 plus 5, which is going to be 21. And then over here, we just divide both sides by 3. And so x is less than or equal to 7. That is the answer for number one. So all x values less than or equal to 7 is going to let this inequality hold. Okay, it's going to make it be valid. Another way you could write this answer here is you can say that x is between, or an element, from negative infinity to positive 7, and then that's a square bracket right there because it's less than or equal to. If it was just less than, then this here would be a circle bracket. All right, so either this or that can be the answer for number one. Now number two, we got negative 5x is less than or equal to 30. Now here you got to be a little careful because if we take this inequality that we're given and we isolate for the x, so we divide by negative 5 at this point. Whenever you divide by a negative, you got to remember to flip the inequality. So this would end up being x is greater than or equal to negative 6, like that. Right? When you're dividing by a negative, you got to flip the sign. Now another way to do this, if you don't want to worry about flipping, is usually when I know I'm going to divide something in front of the variable, I like to make sure that that coefficient is positive. So another thing you could do is you could bring the negative 5x over and then bring the 30 over. So you would end up with negative 30 is less than or equal to positive 5x. And then over here you could divide by 5 and then you don't have to worry about flipping that sign. Right? So either way you're going to get x has to be greater than or equal to negative 6. Okay, and then another way to represent that would be from negative 6 to positive infinity. Remember, negative infinity, positive infinity, they always have circle brackets. And then the square brackets next to numbers are dependent on whether you're including that number like we are here or not. If we weren't including it, if it was just x is greater than negative 6, this would be a circle bracket as well. Right, moving on to number 3, we got x plus 3 has to be between negative 5 and positive 9. Now when I get something like this is a double inequality here, what I like to do is I actually like to split it up into two separate inequalities. So I like to look at this portion. So if I write that, I'll have negative 5 is less than x plus 3, and then I like to look at this portion. So I'll say x plus 3 has to be less than 9. And then what I like to do is I like to solve for the x's here by themselves and then combine the answer. So notice here we would have x is greater than negative 8, right? When we bring this 3 over, negative 5 minus 3 is negative 8. Then over here we would have x is less than 6. So x has to be greater than negative 8, but it has to be less than 6. So if we combine these now into the same answer, we would end up having x is between negative 8 and 6. That's what x has to be in between in order for this inequality to hold. Now another way to show this is we would say x is between negative 8 and 6 with circle brackets because it's not inclusive of those, right? It wasn't less than or equal to 9 or greater than or equal to negative 5. It was just less than 9, greater than negative 5. Right, so that's one way to do it. Another way you could do it is you could just kind of work with it. Let me show you. You kind of work with it at the same time. It's just I feel like doing it this way that I'm about to show you, the risk of making a mistake increases. But what we can do is we could take this 3, bring it over, and then take this 3, bring it over, and we end up getting that same answer. But personally, especially if it gets a little bit more complex, maybe if there's like a coefficient in front, then I like to just do it separately like I did and then combine the answers at the end. But either way, whichever way you do it, x is between -8 and 6. That is the final answer. And then finally, number 4, probably the most tricky of them all, is we got to figure out when is this quadratic going to be less than or equal to -2. Now what we do here is we bring everything to the same side. So this -2 is going to come over. 8 plus 2, those are the like terms. So that would end up being 10 over here. And then we have a 0 left on the right side. So we basically have to figure out when is this quadratic, -2x squared plus x plus 10, going to be less than or equal to 0. And the way that I like to do this is I like to first find out what are the x-intercepts of this. So I'm going to take -2x squared, this quadratic, and I'm going to see if I can factor it. So first thing I do, I'm going to take this negative out. So I'll have 2x squared minus x minus 10, like that. And then I'm going to factor this, and it actually does factor smoothly because 2 times -10 gives us -20. And then what two numbers multiply to -20 and then add up to -1, that b value? -5 and +4. So 2x squared minus x minus 10. We can decompose this -1 to those two numbers that I just mentioned. Then we factor by grouping. Notice from here we could take out a 2. As expected, these two brackets are the same, so we could factor out that bracket, and then we're left with x plus 2. Like that. Right, so going back to this over here, we end up having -2x minus 5, and then x plus 2. Right, so that's what this quadratic factors into. And what's nice is that once it factors, what we can do is we can easily graph this. So notice that what are the two intercepts going to be? Well, when we find out when does this bracket equal 0, it's going to happen at an x value of 5 over 2, positive 5 over 2, or positive 2.5. And then x plus 2 equals 0, that's going to happen when x is -2. So it looks something like that. All right, and then this is not to scale necessarily, but the quadratic is going to look something like this, and then it's actually going through this value, positive 10, and we know that it's opening down because that leading coefficient is negative. Right, so that's how this quadratic looks like, and really the intercepts is the most important thing, the x-intercepts to get, because now, when is this going to be less than or equal to 0? Well, over here and over here. That's when it's less than or equal to 0. That's when the y values are less than or equal to 0. That's when it's below the x-axis. So it's going to happen when x is less than or equal to -2, or when x is greater than or equal to positive 5 over 2. Right, so that there is the final answer for that inequality. And if you want to put it in that other notation, we could say x is an element from -infinity to -2 inclusive of that -2, right? Less than or equal to -2. Or, that's the symbol for or. It's a u when x is greater than or equal to 5 over 2. So we would write 5 over 2 to positive infinity. All right, so that's another way to write the answer. So either that or that is the answer to number